The hit movie Erin Brockovich, a film chronicling the lawsuit against PG&E that was made because of the hexavalent chromium that they had carelessly disposed of, and how it had contaminated a small town in California's water supply, pulled at the world's heartstrings with its images of sick kids and the relatable struggles of a single mom. But for me, it also pulled at my curiosity. What happened after the lawsuit? The answer is not much. Sure, PG&E paid big time, and the hexavalent chromium was remediated, but the use of hexavalent chromium in general didn't end. Hexavalent chromium is used for a ton of things, including wood preservation, inks, paints, dyes, anti-corrosion products, and plastics. What is hexavalent chromium anyway? Chromium, like some metals, has multiple oxidation states. Hexavalent chromium, or chromium-6, is a chromium ion with a charge of positive 6. Hexavalent chromium is usually created in the manufacturing process, but can exist in nature. Hexavalent chromium is produced when lots of heat is used in the manufacturing process, i.e. welding, brazing, melting chromium. Chromium-6 is formed because of the heat. The chromium is not originally hexavalent, but the high temperatures make the chromium lose electrons. This is called oxidation. Chromium-6 can also be found in eroded chromium deposits. Maybe you didn't see Erin Brockovich, so I'll fill you in on why hexavalent chromium is so bad for you. For starters, it can cause a wide variety of problems. For example, asthma, eye irritation and damage, erosion and discoloration of the teeth, respiratory problems, kidney damage, liver damage, immune system disorders, nasal damage, skin irritation, perforated eardrums, which basically means holes in your eardrums, pulmonary congestion and edema, which both mean a buildup of fluid in the lungs, and cancer. Most notably lung cancer, but if ingested, it can cause other kinds of cancer. And that's just to name a few. None of these would be an issue, at least not as a result of hexavalent chromium, if we weren't exposed to chromium-6. Hexavalent chromium gets in water systems when factories do not dispose of their waste properly, and chromium-6 seeps into the groundwater where it can find its way into our wells and taps. What is it about hexavalent chromium that makes it so toxic? Well, your body uses sulfate for a lot of your bodily functions. To your cells, sulfate and hexavalent chromium look pretty similar, so your immune system doesn't try to flush it out naturally. So chromium-6 is now in your cells, so it reduces to chromium-3, which usually wouldn't be a problem, but because it's not reducing extracellularly or outside your cells, it causes DNA damage. Single-strand breaks, like this, are repairable because the DNA can use the opposite strand as a template for repairs. Double-strand breaks, like this, can be repaired because the breaks are so far apart, but when they get close together, like this, the chromatin, or bit of DNA, snaps into two pieces. So what's the big deal? Why should we worry about the broken DNA? Well, what happens is when cells reproduce, the DNA in the cell has to be replicated. If there is a double-strand break, the DNA can't be replicated, or it replicates anyway, but it replicates incorrectly. This is called a mutation, and it happens naturally all the time, and typically the mutations die when they try to replicate. But sometimes the mutations are sort of close to what they should be, so they can replicate, and because chromium-6 causes so much DNA damage, there is more of a chance for these mutations to replicate. These mutations sometimes turn into cancer cells, so that's why chromium-6 is so carcinogenic. Where did this problem even start? Well, before the formation of the EPA, Environmental Protection Agency, in December 1970, there were very few regulations on heavy metals in drinking water from the federal government in the US because of its limited reach. Local governments had to create regulations regarding heavy metals and other contaminants in water on their own. The creation of the EPA facilitated major environmental changes. For example, the Clean Water Act, which is basically to maintain clean water in the US. But this chemical, hexavalent chromium, is still being used and disposed of poorly despite the efforts to regulate what goes in our water. So what can we do to fix it? There are actually a lot of ways to fix this problem. The simplest is to just make it illegal to use chromium-6 in the manufacturing process and in products. It makes no sense to continue using it, especially when companies are lazy and do not dispose of excess chromium-6 properly. But as for the hexavalent chromium that already exists in our soil and groundwater, there are 3 main remediation strategies that we can use. First, reduction of toxicity. We can use chemicals and certain plants to reduce chromium-6's toxicity. There is another state of oxidation of chromium, chromium-3, which I talked about before, that is basically harmless. When we reduce hexavalent chromium's toxicity, we're basically talking about turning chromium-6 into chromium-3. Chemicals like iron filings, or ferrate, can be added to chromium-6 to change it into chromium-3. Algae and other plants and microbes can also affect the toxicity of chromium-6 and render it less toxic. There are also removal strategies that we can use. Most simply, we can move the contaminated soil to a landfill. We can also use ion exchange resins to reduce chromium-6 concentration to a less than detectable limit. Ion exchange resins are used to create deionized water. The resins are little plastic beads with charged functional groups built into them. Charged functional groups are acids, so they create ions by the release of hydrogen ions when mixed in a solution, in this case water. Each functional group has a negative or positive charge. To create deionized water, anion resin reacts with hydrochloric acid. The positive hydrogen ions attach to the negatively charged resin beads. The cation resin beads react with sodium hydroxide, and the negatively charged hydroxide ions attach to the resin beads. This reaction creates H2O. Something else we can use to decontaminate the water are granular activated carbon filters to filter contaminated groundwater. Carbon filters use a bed of activated carbon, a form of carbon that has small pores to increase the surface area so that chemical reactions and absorptions are more likely to happen. Pores are like holes, so if the pores are smaller, things are less likely to pass through. This is to remove contaminants, in this case chromium-6. Think of it like a Brita water filter, except instead of filtering dust and stuff, it filters heavy metals, i.e. hexavalent chromium. Finally, we can use containment technologies to remediate the contaminated groundwater. We can contain this water using grout, a type of concrete, slurries, also a type of concrete, and sheet piling. Sheets of metal interlock together.